Okay, so moving forward with the reaction part in alcohols. And the first reaction on our hands is a combustion again that we studied for alkenes and alkenes as well. And again, the idea is similar. So we're going to have an alcohol molecule. Let's say we take ethanol and we're going to react it with oxygen, and it's going to give us the same products, which is carbon dioxide and water. Okay. And if I were to write this in a chemical format, chemical equation format, so ethanol is CH3OH. And do remember that this equation is going to be, this molecule of alcohol is going to be in a liquid state. Okay. So this is in liquid. Oxygen again, that is going to be in a gaseous state. And carbon dioxide and water are also going to be in a gaseous state. And now to the balancing part. So if you remember, we had a general equation for alkenes and alkenes when you used to balance them. That was CXHY plus Y/4 plus X and forward with that. Okay, but here because the general formula for alcohols now is a bit different. So with the reaction, so for balancing out, the general equation is also going to be different. And what's that general equation? So let me just again write down the general formula for alcohol first. So the general formula for alcohol was CnH2n plus 1. Let me write it better way. Yeah. So that was CnH2n plus 1 OH. Okay, this was the formula. Now for balancing it, what we're going to do, we're going to take this H from here and we're going to add it here. So I can write the same general formula in this format as well. CnH2n plus 2. The only thing I did was I added this hydrogen here and made it 2. And I'm going to put O the same way. Okay, so the general formula now becomes CnH2n plus 2O. What I did, I just added the hydrogen at the other place to make the formula look a bit easier or look a bit cleaner, because this will now help us in balancing out the equation. Okay, so now let's take the same equation for ethanol and now let's balance it. So the first thing that I'm going to do from here, I'm going to take this and I'm going to use this general formula. So this is CnH2n plus 2 and an oxygen molecule plus, in place of O2, I'm going to write 3/2 O2, and with products, which is CO2, I'm going to write N CO2 plus, here I'm going to write N plus 1 H2O. And I know that this looks a bit complex, but trust me, it's going to make balancing out these equations a lot easier. It's going to be a bit time taking, but once you practice this enough, it's going to be very, very quick. Okay. So yeah, now this is the formula this is the general equation that we are going to be using for balancing out. Now, if I were to again balance the ethanol equation, what I can do, I have written down the general equation. I just call this the general equation. Okay. And what I can do now here you know that the N stands for everywhere where I have written, and that stands for number of carbon atoms. Okay. And the number of carbon atoms in ethanol is 1. So N is equals to 1. So the only thing now you need to do is that take this N and place everywhere where you have an N molecule. So there you can place it here, you can add it here, then you can add it here, you can add it here, and then, okay, I just made a mistake. I'll be correcting this very quick because I feel like, so this basically is 3n/2. So you're gonna have it here as well. Okay, and you're gonna place this N at this place. So now what you can do, we can just quickly put in the values in place of N. So this is C1, H2, again 1 plus 2, O plus 3, 1, 2, O2, and you're going to have 1 here, CO2, plus 1 plus 1, H2O. Right, and let me change the color because it's getting a bit confusing. So this becomes 2 plus 2, that makes it, how much that makes it 4. So this is CH4O plus 3 over 2 O2 CO2, because 1 is, you can write 1 in the same manner, sorry, yeah, and you can have 2H2O. Okay, so this is now your balanced equation. And again, if you were to bring this in its raw format again, what you can do simply is to break this down and take one hydrogen molecule from these 4 atoms of hydrogen and place it with H. How can you do that? Again, CH3. So I remove one hydrogen and I placed it here with the oxygen. So now structurally it is right as well. So what we did previously, we reversed it now. We just did that to make balancing easier. Okay, and now you have 3 over 2 O2 CO2 plus 2H2O. And there's one more thing that we need to do here, is that to remove this fraction. And what we're going to do to remove this fraction, we're going to multiply the whole equation by 2. So this 2 cuts down this 2, and you're going to have what? This gets multiplied here. So this is 2CH3OH plus 3O2. And then this multiplies here, so this becomes 2CO2. This multiplies here. Okay. So this is 2CO2. And this multiplies here, so this becomes plus 4H2. And now this is your final equation. I know it felt a lot complex, and believe me, it is not complex. It's just that because it was a very big explanation, that why it felt like it was a very big or very complex. But it's not. I'm going to solve it for one more equation. Let's do it for propanol as well. And you guys will see that this is very, very easy. Okay. So let's take the molecule of propanol. So propanol is going to be, I'll just write the chemical equation. So that's CH4OH. That's in a liquid state, right? And plus I'm going to have O2, then carbon dioxide plus water. Oh yeah, I forgot one thing, sorry. That is going to be, it's not going to be CH4OH, because in propanol we're going to have 3 carbons and we're going to have 8 hydrogens. I just completely lost that one. I went out of my zone, sorry. So that is going to be C3H8OH. So this is your formula for propanol. Now, once we have taken this, the first thing that we're going to be doing is that we are going to be putting the general formula, which what we said was CnH2n plus 2. This is your formula. And what you're going to do with this one, this is going to be 3n over 2 O2. Carbon dioxide remains as NCO2 plus n plus 1 H2O. Right? So what we're going to do next, okay, and here you have an oxygen molecule as well, because we changed the formula. Now, here the value of n is equals to 3. The carbon is 3. So you're going to place it quickly. Okay, so this is C3 H2 3 plus 2 O plus 3 into 3 over 2 O2. This is 3CO2 plus 3 plus 1 H2O. And now you can have the final equation. So that's going to be C3. This is 6 plus 2 is 8. So that's C3H8O plus this is 9, and that's 9 over 2 O2. And then you're going to have 3CO2, that's going to remain the same, plus 4H2O. Okay, and now to remove this fraction, we're going to multiply it by 2. So this 2 cancel out here, and if I just multiply it by the rest of the equation, so that is 2C3H8 O plus 9 O2 into 6 CO2 plus 8 H2O. And I can just quickly make this again into the right format. Yeah. So that is, again, I'm going to take this. So this is C3H7OH plus 9 over 2, 6 CO2 plus 8 H2O. And that's how we balance out this equation. Okay. Yeah. I know that you guys might pointed out one more mistake, and that is that I have in the above alcohol molecule for propanol, I had put the value as C3H8OH, which entirely was C3H7OH. I was thinking that it's not making any sense, but at the last part, hopefully, you see, I'm very good at taking out my mistakes within the lecture. So yeah, so this is C3H7OH, and that's how you balance out these equations, right? And now if I were to move on to the next reaction, I'll just quickly cover that in this same video, and that's the reaction of oxidation of alcohol. Okay, and by oxidation, I hope you guys know that oxidation means removal of hydrogen. Okay, or you can also say addition of oxygen, because both of these things are going to be happening in this, right? So if I were to take any molecule, let's say I take ethanol. So ethanol, and let me just write the wording equation first. So ethanol in liquid again. I'm going to react it with oxygen because that's oxidation. So oxygen is going to come in, and this oxygen, by the way, is coming from an oxidizing agent. And that oxidizing agent is something that we know as KMNO4. Okay, KMNO4. And okay, I don't know why I would put it like this. Yeah, KMNO4, and this KMNO4 is potassium manganate. Okay, so oxygen is coming from the oxidizing agent, and what's going to happen, as we said, we're gonna heat it, and the oxygen is going to be added. The oxygen is going to be added, and the hydrogen is going to be removed. So, in the wording format, how will we write this? We're gonna write. Yeah, I think I'll write it here. We're gonna have ethanoic acid being formed, and I'll tell you how. Plus, we're gonna form water. Okay, so this is the whole equation. Now, if I were to make this equation with, you can say, the format of structure, so how will that look like? Again, okay, one more mistake. There have been a lot of mistakes in the lecture. This is basically, you can say, aqueous, because the reaction is going to be like this, right? And here you have, let's say if I draw the structure, so ethanol is, we know, CH3OH. So this is, okay, no, ethanol is 2 carbon molecule. I don't know why I'm messing up this much in this lecture. So this is C2H5OH. This is an alcohol molecule. You're going to have this alcohol molecule in aqueous, and you're going to react it with oxygen. So, and the way you're going to write oxygen here is like this. Okay, you're going to write it like this, and you don't need to get into the details of why you are writing it like this, because that's not part of that detailing is not part of the syllabus right now. Okay, so this is one thing. Now we're going to heat it, and again, do remember that the oxygen is coming from an acidified potassium manganate from here. I'm going to write acidified so you guys remember. Acidified potassium manganate, and what you're basically forming at this side is a carboxylic acid molecule. And how you're going to form it? So remember we said that what happens in oxidation is removal of hydrogen and addition of oxygen, right? And here you have an OH molecule and you have two hydrogens. And because we're going to add an oxygen molecule, so what's going to happen? These two hydrogens are going to get removed, and so the structure looks something like this. Now you have an OH molecule here. These two hydrogens from here are removed, and instead of that you have a double bonded oxygen. Okay, and now if you notice this, I told you at the start of the series of alcohols that this functional group is of an carboxylic acid. So what's happening? You're starting with an alcohol molecule. You are reacting, or you can say it's reacting with oxygen from an oxidizing agent, which is an oxidation reaction. So you're starting off with an alcohol molecule which is getting oxidized, and you're forming an carboxylic acid molecule and water. Okay, which is plus H2O, and which is going to be in a liquid state. And this, by the way, is also going to be in an aqueous state. Right? So this is the whole idea of the reaction. You're going to have an ethanol molecule. You're going to have you're reacting it with oxygen from an oxidizing agent. You're heating it as well, and then what you're forming is a carboxylic acid molecule in aqueous and a water molecule in liquid form. Okay, so this is the whole reaction of oxidation of alcohol. Right? Okay, perfect.